The Department of Information Technology at Velal College is dedicated to excellence in teaching, research, and innovation. With advanced facilities and a committed faculty, the department prepares students to tackle real world challenges in communication technology and way beyond.
Now, it is my honor to introduce our esteemed chief guest. First, we have Dr. V.K. Manamalasundaram sir, a highly accomplished professor and chief coordinator infrastructure and innovation of Vellalar College of Engineering and Technology. His contributions to the field of advanced communication technology have been instrumental in shaping many young minds. Next, I would like to introduce Dr. R. Mainavati ma'am, Professor and Head of the Department of Information Technology. Her expertise and leadership have been pivotal in driving innovation and excellence within the department. And also, I would like to welcome our resource persons, Dr. B. Amutha ma'am and Dr. P. Akhilandeshwari ma'am, for handling today's session. And finally, I would like to welcome all the faculty members attending this program.
I kindly request Dr. V.K. Manasundram sir to deliver the inaugural address and share their thoughts on this vital theme. Over to you, sir.
Good evening to one and all. I would welcome Dr. B. Amutha Madam, who have joined before the student joined in the session. I really surprised that before the members joined in the session, resource person who is and also chief guest of the today's inaugural, who has joined in sharp 6 p.m. Joined sharp. I welcome you, ma'am, and we thank for your interest shown to us. And today's another speaker of the today's session, Dr. Akhilandeshwari Madam, from the same institution, SRM Institute of Arts and Science and Technology, Chennai. Today going to handle the session. So this is a time I should provide the details how we are conducting the ATAL and how we have experienced in this ATAL. So first of all, I would like to thank our AICT chairman, Professor T.G. Sitaraman, and the team of ATAL members who have sanctioned this 6 days online FDP program on empowering society, leveraging advanced communication technologies for a connected and resilient future. So this is our fifth ATAL FTP that we are conducting. During the Corona period itself, we have conducted 3 online ATAL programs. Followed by that, we have frequently conducted another 2 online ATAL programs by the ACTE. So we not only complete all the documentation which is expected from the ATAL committee, but we are really providing the output to the students, and really in the very last ATAL program is art programming. Our output is mainly based on the student feedback. They really enjoyed the 6 day session and they have provided what will be your next ATAL program, sir, like that they have asked with me. So I am very much happy with our team members. So the team members, mainly this ATAL is initiated by Dr. R. Menaka and the co-coordinator Dr. Ms. Sudha, Assistant Professor in the Department of Information Technology, by which the overall coordination is done by the head of the department, Dr. R. Mainavati, Madam, and this captainship of our college, that is our principal, Dr. M. Jayaraman sir, and our management, people's secretary, Thiru S.T. Chandrasekhar sir, and our managing administrator, Thiru Yuvraj sir, who said that not only you have to provide within the limit which is provided by ACTE, if there is more expenses or anything needed, we are ready to do that. So that also which make us happy to do this ATAL program, 6 days ATAL program. And also our participants, totally we have 119 participants, by which 108 participants from Tamil Nadu and remaining from other states. And also we have 9 resource persons, out of which 8 resource persons from Tamil Nadu and 1 resource person is from Kazakhstan. And we have expected more another 2 resource persons from other states also, which is in the specialization, but unfortunately due to their medical emergency, they are unable to join in this session. So this ATAL 6 days ATAL program, which is the formation of all the 360-degree stakeholders, resource persons, faculty members, our department staff who is executing this program, head of the department, principal, and management. So we should work together to make this ATAL 6 days faculty development program a grand success. The grand success in the sense means the outcome should be taken from our participants and which should be spreaded to more number of peoples. That is the main motto of this program, 6 days program. And also this program, the topic which is given is more interesting, and which is the topic which is in research also. That is, after implementing the 5G technology itself, what all the research experiments, what they have said is, so we can make all the things by using drone technology. For the drone technology, 5G is the most important thing, by which we can be able to make the humanless foods distribution or low kg parcel distribution, and also ADAS features in the cars, which can be communicated via the 5G technology. But what they have given us, the topic which is chosen by us for the 6 days is, what is the positive of the 5G technology and how we can be move to the 6G technology, and what are the futures and what it should be get improved, and what is mean by that 5G technology, and what are the applications of that. If we improve to this technology to the next one, what may be the additional applications that we can be able to move on. So based on the recent trends, the topic was framed by both of our faculty members with many experts, by Dr. R. Menaha madam, Dr. Ganesh Kumar Sudha, and our HOD, Dr. R. Mainavati, have framed all this in keen with the interest of the participants and the real outcome. So next, I will provide the details of this 6 days program. What are all the topics that will be covered in this 6 days program? That is, by today, we will be able to learn looking beyond 5G, the dawn of 6G, by our chief guest and resource person, Dr. Amutha B, professor in the Department of Computer Technology, the SRM Institute of Science and Technology, Kattankulathur, Chennai. And the next by the same department, Dr. Agilandeswari madam, will take next gen communication, paving the way for a ubiquitous society, which will be taken by the Agilandeswari madam. Followed by that, tomorrow the session will be on shaping the IoT landscape, the role of 6G technology, and the significant milestone in the development of mobile communication. And the third day will be aerial innovations, that is DOTS trials for 5G emerging connectivity with drones and balloons, and followed by that next generation communication technology, that is transforming classrooms with holography, and followed by that in the fourth day transforming healthcare, the impact of 6G communication on augmented reality applications in medicine, and followed by that medical innovation with 6G and AR, that is advancing pattern care with new opportunities and considerations. In the fifth day, the two sessions will be one as 6G communication with AR and VR technologies presents numerous opportunities for advancing pattern care, and the next session on the fifth day will be 6G and AR, that is driving performance and societal change uh, through advanced communication, and in the final day ensuring data privacy and securing in AR and VR challenges in next generation communications, real time monitoring in defense, that is leveraging next generation communication for enhanced security, and finally connecting recovery, that is the role of next gen communication in transportation rehabilitations. So followed by that, in the sixth day, we will have the case study that may be mutually discussed between our all the resource persons and the participants, and we shall have those case studies to be implemented for the real time. So this implementation, during the type of implementation, what are all the doubts that may emerge may be covered by the 6 days starting from today to Saturday. So we pray for God, and also having faith with the faculty members of the IT department will arrange the sessions in time and will coordinate all the resource persons, and also with the and also the participants, and daily after the completion of the program, the participants were requested what are the things that may be uh, changed in the very next day, that is in the day one, if there is any change in the style of delivery, or if they need more in this topic, or if they need any real time application what they are giving in this topic may be suggested in the feedback provided in the chat box, so that we may also be able to update in the very next day by informing the student, the participants feedback to the resource person, such that we will be able to make more interesting what the participants were expecting in this session. So I thank, once again I thank the management and our ACTE ATAL team who provide us this chance for providing the 6 days online FTP program, and also the heartful thanks to all the resource persons and also the participants who have interested in joining this program, will make you the valuable outcome at the end of the sixth day. We hope this FTP will provide the realistic output among the participants and also the faculty members who is joined in our college. Thank you.
Thank you, sir, for your insightful words.
Next, we move on to our upcoming session, which promises to be equally engaging. It is my privilege to introduce our next speaker, Dr. B. Amutha ma'am, a distinguished professor and a chief technologist, currently working as head of the Department of Computer Science and Engineering at SRM Institute of Science and Technology, Chennai. She published 50 plus research paper in Corpus or SCI, indexed journals, and she filed 6 patents, and she successfully guided 7 PhD scholars to completion and guiding more than 5 scholars currently. She has impressive 42 years of experience in this field. Now, Dr. Amutha ma'am will take us through the exciting topic looking beyond 5G, the dawn of 6G. Please join me in welcoming Dr. Amutha ma'am to share her expertise with us. Over to you, ma'am.
Thank you so much for the nice introduction. Good evening to all of you. I'm very happy and delighted to be a part of this wonderful event which is being organized by the LLR College. Um, now I'll share the PPT.
Madam, sharing disconnected, I think so, ma'am. Now it is visible, but if you after that you said the now I am sharing the PPT, then only it gets disconnected.
May I share it or not, sir?
Ma'am, now the PPT is not visible in ma'am.
No, I'm sharing now.
Okay, okay, okay. Sorry, ma'am. Yes, ma'am. Yes, ma'am.
I think it is visible to all of you.
Yes, ma'am. Just you go with slideshow, ma'am, so that you will get the full slide, ma'am. Next to animations in the top line, home, insert, draw, and that slideshow, ma'am. The slide will be visible for the entire screen. In the top
I can see some.
header, ma'am. Yeah, slideshow. And top home, insert, draw, design, transaction, animations. Next one is slideshow, ma'am.
No, I'm going there. Okay.
Ma'am, press F5.
Yes, yes.
F5, F5.
Yes, Akila.
Okay, slide share here.
Yes, ma'am.
After this notes.
Yeah, ma'am. From beginning.
After the notes.
Now it is okay. Now it is okay.
Ma'am,
Ma'am, slide
Is it in the slideshow mode? Hello.
ma'am, you have to close the right?
Whether the slides are in the slideshow mode?
Ma'am, 1 minute, ma'am. Amutha ma'am. Close button மேல இருக்கு பாருங்களேன் இன்டு மார்க் ஸ்பான்சர் வீடியோ
நான் போட்டிருக்கேன்
அந்த இத இன்டு பண்ணீங்கன்னா உங்களுக்கு ஸ்லைட் ஷோ எனேபிள் ஆகும்
இல்ல நான் ஸ்லைட் ஷோ மோட்ல தான் போட்டிருக்கேன்
உங்களுக்கு தெரியுதா
எனக்கு தெரியுது
இங்க வியூல இல்லையே மேல பாருங்க why I am seeing this watch now னு இருக்குல அதை க்ளோஸ் பண்ணுங்களேன்
இல்ல அவங்க கிட்டே ஸ்லைட்ஸ் இருக்கு அவங்கள போட சொல்லுங்க அதர்வைஸ்
இல்ல நீங்க வெளியில வந்துருங்க நீங்க வெளியில வந்து திருப்பி
ஒண்ணும் பிரச்சனை இல்லைங்க மேம்.
நான் ஹைட் பண்ணி ஸ்டாப் ஷேரிங் போட்டுறேன்
இப்ப போடுங்க மேம்
நான் இப்ப போடுறேன்
இப்ப போடுங்க
ஸ்டாப் ஷேரிங் போட்டுட்டு போடுறேன்
கொடுக்கல நீங்க என்டையர் ஸ்கிரீன் கொடுத்துட்டு கூட
ஆமா சார் எஸ் சார் Menaka, I sent the PPT to you that if you are able to share, you can also share it.
Ma'am, if you share means it will be okay, because if you want to change the slide each and every
Transition.
time, you have to depend on us. That's what I am requesting you to share, ma'am. Amutha ma'am,
Yes, sir, I'm sharing.
you just give the entire window
Yes,
so
sir.
that you will have the entire control, ma'am. While you are sharing, before what you done is you have shared the particular file so that you may be able to happen such mistake. Sorry, such provisions will not be enabled. If you
I
give
can
the entire
understand.
screen to be shared, then you will be able to do all those things.
Whether it is visible, sir?
No, ma'am.
Not visible?
Ma'am, it is visible but without slide share. Go to the slide presentation view.
This is my slide presentation. I put a slide show. Now it is
Slideshow.
now it is okay. For
No,
me,
ma'am.
it is
No, ma'am.
coming full screen.
For us, it is only the part of it.
மேம், நீங்கள் ஷேரிங் பண்ணிலிங்க மேம். என்டையர் ஸ்க்ரீனை ஷேர் பண்ணணும் மேம். நீங்கள் அந்த ஷேரிங் விண்டோ போவையில் பார்த்தீங்க அப்படின்னா, ஃபார் எக்ஸாம்பிள் வந்து
Working, sir, entire screen.
இல்லைங்க,
Screen share பண்ணிட்டேன்.
அதாவது பார்த்தீங்கன்னா குரோமு விண்டோ என்டையர் ஸ்க்ரீன்னு சொல்லி இருக்குங்க மேம்.
ஆமா சார், entire screen தான் I'm sharing.
என்டையர் ஸ்க்ரீன் கொடுத்து ஷேர் கொடுத்துருங்க மேம்.
Yes, sir, I'm sharing that only.
என்டையர் ஸ்க்ரீன் கொடுத்து அந்த என்டையர் ஸ்க்ரீனில் கிளிக் ஆன் தட் என்டையர் ஸ்க்ரீன் அண்ட் தென் ஷேர் மேம்.
Now it is shared, sir. Again, the same problem. Menaka, I send the PPT. Otherwise, you can also share from your side.
Ma'am, please share that.
PPT is viewing, but you are saying that for me it is in slideshow, but for you it is not in slideshow.
Yeah, ma'am. Yeah, ma'am.
But for me, I put it is in slideshow.
Ma'am, go ahead with the same.
Is it coming like slideshow, sir? Now? No. 1 second, sir.
Ma'am, it's okay. You can start your session, please.
Okay, sir, I'll try my best.
Ma'am, if you have PDF, then you should try PDF. Sometimes this PPT sometimes makes error.
Madam, shall I share the PPT, ma'am?
Now it is okay,
Yes,
sir.
ma'am. Perfect.
Okay,
Perfect,
perfect,
ma'am.
ma'am.
Perfect.
Perfect.
Sorry for the delay cost.
Ma'am, please share again, ma'am.
Share again.
Yeah, same thing. What you have done, you please share it
Same
again.
problem, sir.
Yeah, ma'am. It's now it is invisible.
Now it is coming as full screen or not?
Ma'am, please share again, ma'am. Now it is not visible to. கேளுங்க பக்கத்துல அங்க விசிபிளான்னு கேளுங்க. Ma'am, please share it again, ma'am. Ma'am, shall I share it, ma'am?
I will share it again, sir.
Okay, okay. That's perfect, ma'am. Perfect, perfect. Okay, ma'am.
So now it is clear, sir.
Yeah, perfect, perfect, ma'am. No problem.
So the topic chosen is looking beyond 5G and the dawn of 6G. 6G actually 5G and 6G. 6G actually reduces delay, but the delay has been caused. Okay. So the agenda of the presentation goes like this. Introduction, the journey of wireless technology. What is 6G? What are the key drivers for 6G development? The core features of 6G, technologies enabling 6G, impacts of 6G, challenges in 6G development, roadmap to 6G, sustainability in 6G, the role of AI, machine learning, and all that in 6G. And finally, we have a conclusion. So let us see why we require this 1G, 2G, 3G, 4G, 5G, and all, and what is the evolution, how the evolution has occurred in the society. We know that we people have to get connected in the modern life, and we need innovation, we need productivity, and we need global economy. That is why we have gone for 5G. 6G will come into picture in the year 2030. They are talking about, they started the work 5 years before, I think. 2020 itself, it was started, and there was 2025. They said it will be emerging, and in 2030 definitely we will be having a 6G mobile phone in our hands. And now we have 5G, and 5G brought low latency actually for and high speed communication. When it is having low latency and high speed communication, because of real-time holographic experiences and digital twins. Digital twins, again, we have a simulated environment of what will be the future building construction, or what will be the future environment, and let us see how the future environment is going to look like using the digital twin technology. For all this, we need 5G, because fast communication is required, and more number of IoT devices are also available throughout the world, and we started collecting lots and lots of information from the sensors and IoT devices which are penetrating the entire human lifestyle. So 6G will, apart from 5G, 6G will focus on intelligence, machine intelligence, and adaptability to the environment, and ultra connectivity. The ultra connectivity is something like how you can get connected with not only with the countries, not only with the states, not only with the cities or something. You can get connected even from planet to planet. So in that way, they are thinking, that is why 6G they are focusing more upon, and all the IITs and all the top companies are also concentrating more on 6G technologies. They want to integrate AI and machine learning, Gen AI technologies into the network operations. And coverage through space-based communication, as I said, satellite integrated 6G aims to achieve global and even interplanetary creation. And a lot of they will be used in a lot of telemedicine techniques, smart cities, autonomous vehicles, and virtual environments. We know that holographic techniques as well as AR, VR, XR techniques are coming into picture. And the value of mobile networks to our economic and social development. Slides are changing or not, sir? Hello? Are you able to hear?
Madam, able to hear, and
Slides
PPT
are
is
changing?
also clear, ma'am. No problem, ma'am. Please
Okay, so
continue.
slides are changing, sir.
Yeah, correctly it's going, ma'am.
Thank you very much,
No
sir. Thanks
problem.
for your patience. So the value of mobile networks, definitely we are moving from one location to other location. We are earlier we were having home at the home we were having telephonic networks and telephones at the houses, and wherever the locations are, they are not able to move. Now we are having mobile phones at our hands, and we can take our mobile phone anywhere and any place, any location, any time. So it is possible to have a small handheld device in our hand. So all these are because of they started utilizing the mobile phones in an experimental purpose in a small island, and they started communicating with each and every mobile phone. And when it was successful, then it has come to the other parts of the world. 5G, when it comes at the end of 2019 and having an IMT vision, mobile technology, International Mobile Technology Vision, 2020 vision, they started discussing about 5G. So 5G starts about the downloading speeds, because from the satellite only we are getting all the data. And when we started downloading the information from the satellites, because all the systems are connected to the servers, all the servers are connected to the cloud, and all the cloud information are connected to the base station, and from the base station it is connected to the satellite, and from the satellite we have to download everything. So through the base station again we are downloading everything. So when we start downloading all the information through the satellite, definitely the downloading speed, whatever device which we are having in our hand, that is not sufficient for us to get the data extremely at a faster rate. And machine to machine IoT connections, all these are the need or the criteria for going for low latency for critical applications, critical communications. Critical communication in the sense, again, the military communication or emergency situation, again, healthcare sector communication, all that, because a patient's life is very much essential. Even within a second or a minute, patient's life is expected to be safeguarded, expected to protect the life of a person. So the time is very, very essential or crucial in that particular situation. That is what called as critical communication is. So in the where it will operate. They are expecting that they have decided the frequency, that 700 megahertz and 3.6 gigahertz. 5G will be operating. 5G is operating, and 6G they are having other bands for licensing. And the journey of wireless technology, as everybody knows, 1G. That is the initial one, analog mobile telephonic system, AMTS, that is analog voice calls, launched in the 1980s. Before that, we were not having any mobile phone system, analog voice call system. And the 2G GSM again, global system for mobile communication. We started communicating messages, we started communicating text information voice information, etc. And to go for faster information, we have gone for 3G, 3GPP, LTE, and all that. And in 3G, we have faster data for mobile internet, and internet was introduced through mobile during that time only. And again, we have gone for 4G because of the advancements in the technology. We have gone for 4G technology. That was a high-speed internet. We need a higher speed of internet for streaming data. So when you start playing a game in the computer, or when you start realizing a movie, watching a movie in the system, watching a movie in a computer or in your TV, what happens actually? The streaming data. Or you want to watch a sports program, continuous real-time sports program, or real-time surgery you want to watch, real-time information you want to watch. And then streaming is very much essential. And a lot of streaming technologies as well as streaming protocols have been, 6G kind of protocols have been invented and implemented. And due to that, we were able to get the fastest communication through mobile applications. So that is how high-speed internet comes into picture in the domain of period of 2010s. Again, in 2020, at this particular stage, we want to have ultra low latency, that is millisecond time only. We are able to wait for information to reach from one device to other device. And massive IoTs, again, many number of IoT devices, home automation systems, patient monitoring system, traffic analysis, traffic identification system, all that. We are connected with the smart environment, smart TV, smart pollution monitoring system, smart platforms, smart dustbins, smart, everything is smart environment. The entire environment, we want everything to be smart. When you enter into a hall, automatically the door has to open. When you go into the room, automatically the lights and the fan or the AC to be switched on. When you go away, everything should be switched off. All these are automatic technologies. So we want everything, all the devices must understand our presence and they act accordingly. Means then we want massive amount of IoT devices to be placed in so many places of our environment, and massive IoT connectivity is required. When it is the case, then we need ultra low latency devices and highly reliable devices. So all the devices, sensors, actuators, and the entire system has to be connected well, so that we can get the reliable data. So that is how 5G comes into picture. So this is a journey of wireless technology, and even 5G is there available. Then why do you go for 6G? 5G itself is sufficient. So when 5G itself is sufficient, why do you need to go for 6G? What are the limitations according to 5G? What's next? So we have some limitations with respect to 5G. So limited reach and signal penetration. Even though 5G is there and we have low latency technologies, so Zigbee and all other devices, your near field communication devices, Bluetooth and other devices which we are having, all these are connected in an IoT platform or IoT ecosystem. Then the 5G networks are struggling with the penetration through walls and buildings. They are not penetrating. They can't go beyond 2 walls or to one building to other building, or one floor to other floor it can travel. Then one building to other building, the signal cannot travel. And high frequency bands, so that is millimeter wave. They are having very short range communication. Millimeter waves are coming at a short range communication, and they are not able to be expanded to a larger range of communication in terms of kilometers. So actually dense infrastructure is required for that. And rural and remote areas, how to take 5G towards the rural and remote, that is the problem. So this is a problem with respect to the reach and signal penetration regarding 5G technology. And then higher power consumption. Definitely when you go for higher radiation also affects us, like that people are saying. And experimentation is going on other side, that whether the signal radiation affects our health or not. That is why we have been asked to keep our mobile phone away when we are sleeping at your bed. That way they are saying that smallest radiation will also affect our health. So higher power consumption is required for 5G comparing to 4G. You could have seen a lot of base stations as well as relay stations whenever you travel from one location to other locations. In Chennai, there is a relay station. Likewise, high power transmitter stations, and low power LPDs are there, HPDs are there on top of the mountains or on top of some buildings, or with a height of 50 meters and 100 meters. You can find some towers. So they'll be used for relaying the information from one location to other location. So installation of those particular tower and the hardware infrastructure which is required all this are very much require in terms of operational cost and increased environmental impact. That is why higher power, and the limitation is again higher power consumption. And third point is inability to meet the future data demands. Definitely, the number of IoT devices increasing day by day. We started using only earlier we were having only one phone at our home, one homemade home phone at our home. Landline phone we will be having. But we were having. Now we are having, in addition to that, everybody is having mobile phone. So each and every one who is available at home, we are always having our own mobile phones. Son is having a phone, father is having a phone, mother is having a phone. Like that, we are having our own mobile phone. The number of devices are increasing. The gadgets are increasing. Whenever it is getting increased, automatically data is being transferred from one system to other system. So the largest amount of data is being transferred. So when largest amount of data is being transferred, the bandwidth or the frequency range through which the data has to be transmitted will also exceed beyond a particular limit. So that will also exceed the 5G's capacity. And holographic communications, when you want to see holographic communications or 360-degree coverage or 3D visualization, definitely you need to cover the image or the picture or the video in all the directions. When it is required, the number of frames per second which is being transmitted from one device to other device, which will also vary. Number of 24 frames per second through the gadgets, computers, and 25 frames per second for movie and all we are transferring. So the number of frames which are being transmitted, how many number, again stretching the frame, stretching the information, again all this many technologies will come into picture. What information has to be transferred, which information has to be condensed, all these are the technologies again operating upon these type of communications. Again, AI-driven devices, digital twins. Digital twins again will be the pioneer, or it is going to be the landmark in the near future for demanding ultra high speeds and reliability. So it covers largest amount of data. It is a simulated information about what is going to be made available in the future. Even if you construct a building, then automatically before the construction of the building itself, using a digital twin, you can see how the building will look like in a 360-degree visualization, where and all the flaws will be there, how we can remove that. The same way, a smart city construction, you can use digital twin for new surgery, the tumor which is available inside our body, or whatever diseases are available, whatever flaws are available inside our body. If you want to visualize that using digital twins, it is possible for you to visualize in all the directions. So when the data is being transmitted, the same data is being transmitted from a location to other location using mobile phones, it needs through 5G, it needs ultra high speeds and reliability. So this is inability to meet the future data demands. And the need for faster, reliable global networking is required. That is why we are going for 6G. What is 6G? Again, it is a sixth generation technology. So people are saying, and the committee people, IIT people and other people, the company people who are all the members of the committee, they are saying that even our IIT professors, Bhaskar Ramamurthy is one of the member in the 6G committee, and they are also saying that it will be debuting in the year 2030, marks the next generation communication technology. So there are a lot of boundaries available. All the boundaries will be overcome by means of its speed, reliability, and intelligence. They are estimating how many devices or gadgets are going to be utilized or going to evolve in 2030, and how much population is going to utilize, how much amount of data explosion will occur every day, every second, everything is being estimated. In that case, to that much amount of data is going to travel around the limited bandwidth, and what amount of technology will withstand with respect to the data transfer. In that way, 6G comes into picture. And the key features, definitely ultra high data rates, 1 terabit per second is required for establishing 6G technology for large scale data transfers and real time computing and streaming and all. Low latency, already I said for 5G it is 1 millisecond, and now it is sub 0.1 millisecond latency. Sub 0.1 millisecond latency. Lesser than even 0.1 millisecond latency is required for 6G. Within a fraction of a millisecond, we want the data to receive to our mobile phone for our gadget. In that way, we want the data also to be transferred, because within that much time, you can avoid the accident, you can safeguard a life. Within that much time, we can safeguard a patient's life. Within that much time, anything can be done. So in that way, they are able to understand why this much latency, low latency requirement is essential for 6G and real-time mission critical applications. AI definitely all the electronic devices or the gadgets, whatever IoT devices, whatever we are having in hand, they are all not having their original cognitive skills. Remember, so when cognitive skills are human is having cognitive skills and that is being incorporated into the mobile robots or agents, agentic communication is there, RAG, retrieval augmented generation, LLMs and all that are there. So in that, if you are able to incorporate the cognitive skills into the machine, definitely the machine will overcome us on one day. But anyhow, the algorithms on the procedures are going to be developed by us only. But that is why we want to integrate AI in order to avoid biased judgments, because devices are used in judgment also for law, for judgment, for police, for everyone, for everybody. They started utilizing the artificial intelligence. So AI is going to be integrated in 6G. They are integrating right now. So the spectrum, what is the spectrum requirement? Terahertz spectrum. Again, spectrum in the sense, what is the spectrum? Visible spectrum, electromagnetic spectrum is there. Within the electromagnetic spectrum, we are using the radio frequency band, and apart from the radio frequency band, what is the whether we are able to utilize the millimeter wave communication, ultra high frequency communication, UHF, VHF, all other frequencies, whether we can incorporate when we can make use of that. So those frequencies, again, we have shortage of spectrum because the entire world is utilizing only that particular spectrum. So within that spectrum, we are not able to accommodate all the devices to be operated within that spectrum. So that's the problem. So in that case, what we are doing, we are again calculating the spectrum efficiency and cognitive spectrum, electromagnetic spectrum modeling and all that. A lot of research is going on in that direction. So you know that licensed users are having the licensed frequency bands through which they can operate. Unlicensed users as well are also there. The primary users who are all utilizing the spectrum, they won't be utilizing completely at a particular point of time, and some spectrum will be left out by them. So if it is left out, that left out spectrum can be combined together for the effective utilization of the spectrum. That is spectrum management and spectrum modeling and spectrum design and all. So all this will again comes into picture into the terahertz spectrum, which is required for 6G applications. Again, digital twins need enormous amount of spectrum. Autonomous system, autonomous vehicles. Already you know about very much. You know about Tesla and what Elon Musk is doing, and autonomous cars, autonomous vehicles are going to come in picture in the near future, and immersive virtual experiences. So you know about what is augmented reality and virtual reality. Virtual reality. See, we are connected through virtual reality. When you are sitting there, I am sitting here through the virtual devices. We are able to get connected with each other. So, and what is augmented reality? So you can bring some of the objects which are digital objects which are available in and around with you, that can be brought into your screen or your area, so that you can visualize those objects which are not actually available in your environment. You can bring it back. The digital objects you can brought it towards your environment and make your environment looks like realistic or whatever the way you desire. So that is your augmented reality. You can enhance your environment, that is by augmented reality. So your virtual reality and augmented reality, all this can be a part of your XR. XR is your extended reality. You can experience your extended reality by means of combining the virtual reality and augmented reality. So these are all some of the factors why what is 6G and vision. What is the vision for 6G? Because people, all the learned community people are sitting together and they are finalizing with respect to why 6G is required, how much radiation will be coming out of 6G when we started utilizing the 6G mobile phones devices, and why it is required. So connecting everything everywhere. That is a basic idea. We want to get everybody gets connected. Not within the globe, we want ourselves to be connected. Already you know that how we have sent a satellite to the moon, and how all the countries are sending satellites to Mars, moon, Jupiter, wherever they want. They are sending almost many satellites are revolving around in low Earth, LEO, MEO, and HEO, low Earth orbit and medium Earth orbit and high Earth orbit. So a lot of satellites are revolving around for different purposes. SRM has also established one satellite which goes around the orbit to understand the pollution control and other things too. So in that way, you can also send your microsatellite with the help of the ISRO or the satellite research organization. And these satellites are collecting information from the Earth. They are having a lot of cameras, inbuilt cameras in the satellites. Those cameras are monitoring the entire Earth and they are taking pictures, and again they are sending it to us, sending those photos or pictures or videos towards us, and we analyze what is happening here, whether there is a drought, whether there is any water, whether there is any war, whether this place is greenery, whether this place is suitable for the people to live. Like that, they are able to understand from the photograph. They are doing lot of experimentation over those photographs and videos, and finally they are coming to a conclusion about the globe where we are living. And then also it is analyzing the atmosphere, it is analyzing the planets. So what is our idea about 6G? We want to get connected with the planet to planet. We are living in one planet. We want to get connected with the people living in other planet. Already, you know, there's some people have gone to moon, and they are also there. And interplanetary connectivity is being established. That is why they are able to communicate with us, and our scientists are able to communicate with them. So for that, we need ultra high frequency and highest connectivity, seamless interconnectivity is required. That is why we need 6G, bridging the gaps in rural areas and extending the networks in an outer space. Now, apart from the atmosphere, we want the communication should pass upon. That is through air only you are able to hear my voice, and through air only I am able to hear voice. Air is the communication. Beyond air, how the communication occurs. Outer space, how the communication occurs. So that is one point why, what is the vision for 6G. And transformative application, you know, smart cities are already available. Some of the cities in India have been converted into smart cities, tier 1 cities and tier 2 cities, you could have known. And the IITs and some of the companies, they have come forward to bring smart dustbins, smart pavement, smart railways and smart buses and everything, smart environment, smart malls, everything. So intelligent infrastructure for energy management, traffic control and urban planning, all these are coming under smart cities. Interoperability among the IoT devices is the main basic idea for the establishment of smart cities. And rural connectivity, you bring high-speed internet to the remote and rural areas. If you go to your village, then you may not be connected with your mobile phone through the internet. That is a problem. And how to get the rural areas also to get connected with the internet. So reducing the digital divide, because it is dividing the city with the urban or rural area. So that should not happen. Urban area can get connected, rural areas are not getting connected. That should be avoided. Seamless connectivity throughout the globe, and not only throughout the globe, beyond the globe also. That is the meaning of, that is the vision for 6G. And interplanetary networks. So in between one planet to other planet, automatically you have to enable the communication. Earth mission and space missions are many, and satellite pairs, the scientists who are working in ISRO, they are saying that every day it is hectic for them to understand the logics and what purpose they are sending the satellite, because every satellite is sent for one particular purpose or two purposes, three purposes, like that. So everything is analyzed by them, and they are able to experiment everything, and then they are sending the satellites to the other places, to the orbits, to the space mission. So to identify the space exploration, whether new star has been identified, whether new planet has been invented, like that, they are able to understand from planet to planet by sending information, by sending satellites. For that, definitely communication is very much essential. And real-time revolutionizing communication, holographic virtual meetings, education, etc., advanced IoT ecosystem, interconnecting all the IoT devices. And 5G versus 6G, what is our focus? 5G, speed and low latency for IoT and smart applications. But in 6G, we are going to incorporate AI. What is the purpose of us to incorporate AI into 6G devices? It has to think. We want the device to think on its own. That is why we want to go for 6G devices, AI native networks, and intelligence that the machine should has its own intelligence to react in an environment. In that way, cognition is being incorporated into that. Intelligence is, they're not saying about cognition, they are saying about intelligence. So that type of intelligence is being incorporated into the device so that the device can react to the human's emotions like that. And adaptability in a particular environment, the device can get adapted into environment. A device which you are using here, your mobile phone you are using here can work if you go to a foggy region or Atlantica or Arctic region, it may not work. So that's what adaptability is. And the data speeds, 5G data speed is 10 Gbps and up to 60 data speed is up to 1 terabits per second, bits per second. And latency is 1 millisecond, as I said. For 5G, it is sub 0.1 millisecond. See how much speed it is. And spectrum, we use millimeter waves here. There we use terahertz spectrum. And applications, all the IoT device applications, streaming of data, because we are able to visualize, we are able to see the movies in the TV automatically. We are though there is no buffering. So in a buffering is not there, streaming is perfect, and smart city applications. But in 6G, what we are doing, holography and ultra high latency, ultra high tension devices are being available under 6G, holography, advanced IoT and autonomous system, intelligence, emitter network intelligence is given under 5G. But here in 6G, definitely extra intelligence is there because it is AI-driven, self-optimization and real-time decisions. Connectivity, it is terrestrial, only within the globe we are getting connected. But coming to 6G, definitely you could have global and interplanetary coverage. And that's all about this 5G and 6G. What are the key drivers? What do you want? How do you implement 6G? What are the key drivers which are driving 6G development? It is the growing demand for immersive applications like holography and extended reality. I said what is extended reality? The combination of this and that. That is AR and VR. So ultra low latency and massive bandwidth is required for the holographic communication to interact virtually, because it is bringing the communication mode is bringing our people in front of the system. Wherever, irrespective of the location. See how much it is. See, you are sitting at San Francisco, or you are sitting at Coimbatore, I am sitting at Chennai. Somewhere we are sitting. But how we are able to get communicated, how our images are clear, how our voice is able to hear. So all these are because of the communication only. So ultra high tension devices are also a part of 6G for extending holographic communication. XR, I said about XR, these are the pillars. And second one is autonomous systems in transport and healthcare. Definitely autonomous car, Tesla, I said healthcare is a key application driving the development of 6G. Healthcare, definitely within a fraction of a second, you need the patient has to be taken to the hospital, and communication, irrespective of the remote surgery applications also we have seen, the doctors can be at different locations and different hospitals, and they can suggest or they can participate in a surgery of a patient at a different location. So that is possible. That is what healthcare, where the communication plays a major role. Even if sub millisecond will also affect the life of a patient. Self-driving cars, real-time communication, ultra low latency for safety and efficiency, vehicle to vehicle connectivity, vehicle to everything connectivity, everything, all other devices. That is seamless traffic management. And remote surgeries require continuous high bandwidth, because during the time of surgery, if the communication breaks, what will happen? It is the life of a patient. That is why these are all called as life critical applications. And for these life critical applications, we need 6G. That is why they are going for 6G. Holographic and tactile and haptic applications, highly digitized smart cities, XR applications, space travel, flying vehicles, brain computer interface. All these are some of the application, emerging applications. And coming to AI, machine learning and IoT under 6G, AI and ML are pivotal for adaptive networks. Definitely, we in all the domains we started using artificial intelligence and machine learning. So artificial intelligence and machine learning deliver intelligent network management as well as self-optimized networks, because when you want to communicate, the network has to be self-optimized, and if there are any problems in the network, automatically it can come back to it will rectify its fault, and it should come back to its original situation. That is, resiliency should be incorporated into the network. So wherever, even if it is a network, or if it is a sensor, or if it is a device, or if it is the path for communication, or whatever devices which are participating in the communication, router, gateway, or the edge devices. What are the edge devices you have come across? Your sensors, actuators, hubs, routers, gateways, all these devices. So all these edge devices, when they started getting the data, if any error occurs, automatically they should come back to its position. The network should come back to its original position and start communicating. So even if you miss 1 sub millisecond of communication, something may happen. Some errors will occur. It may it may make us to lose the life of a person. So that is why, because accident avoidance, all that. To predict the network failures and optimize the performance and the energy efficiency, we need AI to be incorporated into the 6G systems. And IoT is growing scale. A lot of IoT devices, smart homes, wearables, industrial IoT system, autonomous systems, ultra reliable and low latency communication is the main factor of 6G. Massive device communication is the main factor of 6G. And data demand, and coming to the data demand and spectrum efficiency, you can see low bands FDD, frequency division duplex below 1 gigahertz, that is approximately 20 megahertz bandwidth, and mid bands FDD and TDD, frequency division duplex and time division duplex in the range of 1 to 7 gigahertz, and upper mid bands time division duplex, you have 7 to 24 gigahertz, and millimeter wave, again 5G is coming into picture, 24 to 71 gigahertz, and sub gigahertz. This is 6G actually, 100 plus gigahertz, because it is operating with a gigahertz range, sub gigahertz range. And this is the spectrum. How you can see how the band is. The sinusoidal wave is having a lot of breadth in the x-axis. What is the meaning of that? X-axis is always y-axis is your y-axis is your amplitude, and x-axis is your what is your x-axis and what is your y-axis. We can see how much is the amplitude by seeing your y-axis, and how much is the time by seeing your x-axis. So if the waves are like this, they are carrying lesser amount of information. If the waves are like this, you can see the waves are carrying highest amount of information. And coming to the use cases, this is in the low band, you can have low data rate and low coverage and low power IoT. And coming to the mid band, you can see ubiquitous coverage. You can connect everything, and macro capacity level, wide area devices. And upper mid bands, macro capacity and millimeter wave capacity hotspots. And here you can have planetary communication, also data center communication. Data center, very big data centers are there. You know what are the data centers? You can see, visualize some of the data centers which are operating. Data center, not only one data center they'll be having proxy data centers also. For that also, power consumption and all other things are required, and communication between those data center to data center also. It is a hectic one. For that also, you need to do some modifications with respect to the existing communication technologies. That is why 6G comes into picture. So how the wider coverage of the signal is, and how the higher capacity signal is. You can see the differences in the sinusoidal waveform, which is being transmitted from one location to other location through the mobile devices. And explosion in data-driven applications, you can see the video streaming capacity, also 4K video streaming or 8K video streaming, which will tell you how the video streaming is done through your mobiles or through your any of the devices. And immersive gaming, you can involve yourself, you can immerse yourself into the game, and you can play the games against the computers or against the system. And cloud-based services will require significant bandwidth and ultra low latency applications. So when you choose for selecting 6G applications, you can find out the significant bandwidth as well as the ultra low latency for enabling these technologies. And second one is, what is the data demand for spectrum efficiency? In the better spectrum utilization and energy efficient networks, terahertz spectrum, as I said, and that is the energy efficiency. Again, you are not supposed, because almost billions and billions of devices are going to get connected with each other, and they are all the devices are participating within the network. Then what will you do? So how the energy efficiency is going to be? The energy should not be wasted actually. So energy efficiency is a critical factor for 6G. And AI powered optimization, a lot of optimization algorithms are there. How will you optimize? Because when you transfer the data, already you transfer some data, and so only the modification of data alone can be transferred. Means you can keep the previous data as it is, the modified data alone can be transmitted. Like that, you can have n number of modification or optimization algorithms. And dynamic spectrum sharing, again, dynamic spectrum sharing means the primary users, they can use some part of the spectrum, some portion of the spectrum, they may not use it, and those spectrum can be reallocated, and reallocation in spectrum sharing can be done by dynamic spectrum sharing algorithms. And utilizing that, the entire spectrum will be completely utilized for the purpose of transferring your data from one location to other location, or one device to other device, or a group of devices. And coming to the core features of 6G, multi-band, ultra-fast speed, energy efficient communication, AI incorporated in all the devices, and high security, secrecy, and privacy are the basic features, key features of 6G. Under multi-band and ultra speed, you can have visible light or spectrum. So high speed connectivity, where will you go? You can see how light, what is the speed of light, 3 into 10 to 8 meters per second. So you can use visible light spectrum. Li-Fi is light fidelity. Li-Fi technology is there. You can go for visible light spectrum. So enormous spectrum is available in visible light that can be utilized for transferring the data. So you can see two LEDs connected to one LED can be a transmitter, the other LED can be a receiver. From one LED to other LED, you can transfer the data. You can see the visual boards on the roadside shops or wherever you can see. So from the LEDs, you can see the words are blinking or words are moving. What is the meaning of that? It is being transferred. The data is being transferred from one LED to other LED. So that is a data transfer. And what is the spectrum range for the multi-band? Spectrum range for the multi-band is 0.1 to 10 gigahertz in that. And energy efficiency, you can have wireless charging or inductive coupling or magnetic coupling that you could have studied in your UG classes. Energy to be harvested from the sunlight, you can collect that, because you can see the how many panels or solar panels are available to collect the energy. You can utilize it for your household purposes also. So that energy can also be utilized, because we need the energy to be harvested from ambient radio frequencies. You can choose the energies. The energy should not be wasted. Wherever it is possible, you can collect the energy and you can utilize the energy. AI, again, service intelligence, environmental intelligence, operation intelligence, wherever you want, you can incorporate the artificial intelligence. What is artificial intelligence? You can incorporate your machine learning. Your machine can think and react according to the user's desires. The machine can act accordingly. And high security and secrecy and privacy application, you can have distributed management, distributed computing, distributed mechanism for multi-level security. Because in biometrics and all, you can very well see unimodal security systems are having failure, and we are going for a multimodal security. All the features have to be combined together, and that the features, the combination of those features will become a unique feature set, and that unique feature set is used not for hacking that particular system. And again, quantum key distribution. How will you say? Quantum is highly secure. If the computers are constructed using quantum technologies, quantum computers will be there in the near future automatically. Definitely, largest amount of 6G technology is very much required. Why? Because zeros and ones we are transferring, because all our data is being converted into zeros and ones, and the entire amount of data is being transferred in terms of zeros and ones. The combination of zeros and ones, all our analog data is transferred into digital data in terms of zeros and ones. Again, if you take quantum, the sub values between 0 and 1, you can have a number of values, a number of divisions between zeros and ones, and you can transfer the data. You cannot how will you penetrate that data? It is not at all possible. You are not able to penetrate that data. You are not able to hack the data if the data is in terms of quantum. If it is a quantum data, if it is a quantum bit. So secret, high level of security and secrecy can be incorporated. So all these are some of the core features, and the target speed is up to 1 Tbps, and the real-time AI processing, UHD video streaming and all. So what are the applications? Media, entertainment, scientific research and all. And real-time AI, AR, VR, XR, UHD streaming are some of the applications related to 6G, as I said. High resolution graphics and real-time rendering, lag free, time lag. No, without any time lag, we are able to see the instant outputs. And sub-millisecond latency, again, it is a key feature of a real-time application and real-time communication. The interactions with the virtual environments and virtual instances and virtually instantaneous interactions can be providing a real-time communication, and the users can have a seamless experience with precision. What are the use cases? Telemedicine, autonomous vehicles, and industrial IoT, and many applications are there for that. Real-time high-definition video, remote surgery, and telesurgery, if possible, they have given. Autonomous vehicles, you know about self-driving cars and autonomous drones, which are flying all over the area of the land. Now, high-precision agriculture has come into picture. In that, what they are doing, drones are getting flown on top of the agricultural sector, agricultural land, and they are able to visualize the growth factor of the plants, and then they are able to send instantaneous informations then and there, and we are able to monitor. We can sit somewhere else and we are able to monitor the entire field and give directions to the people who are working there, and try to increase the yield of the agricultural plants. So this is a project. Many places this kind of projects are going on. Autonomous agriculture, autonomous vehicles, to avoid collisions. Automatically the car or the device or the bus or the vehicle in which the system is available, it will not collide anywhere, and it optimizes the route and reaches the destination within a short span of time. And coming to the industrial IoT, we can see the manufacturing process can be optimized. Industrial IoT in industry 4.0, 5.0, many things are coming into picture. Automation, robotics and automation is the basis for industrial IoT. So the machine can look into its own aspect and see how much lifetime is, how much speed we are working, and how much lifetime is left back with us, and whether we can run fast or reduce our speed like that. It can think and come to a conclusion about itself. So this is also one of the artificial intelligence technique which can be incorporated to the industries. Automation is the major thing. For that also, for automation, continuous data has to be monitored. Again, 6G has to be is required. And global coverage, as I said, not only in the globe we are going to monitor, we are going to communicate. Interplanetary application also we are going to look into that. When you are incorporating, when you want execute 6G applications. So integration of terrestrial and satellite networks. 6G will combine the traditional terrestrial networks, cell towers, fiber, etc., fiber optic communication, etc., satellite communication also, ensuring the global coverage and ubiquitous global communication system. And second one is urban and rural connectivity gaps. It will the digital divide will be avoided, as because of the fastest communication, it can reach anywhere. Satellite based systems will cover the entire area. And a lot of applications. This is also one of the application. So for this application at a faster rate, without any flop, without any error, so the data can get communicated to the participants. And how the final one is AI integration. How AI can integrate? AI can manage the networks dynamically, ensuring the optimized performance. What's the meaning of that? AI can be applied anywhere, any device. If you think of any of the artificial intelligence algorithm which can see in all the directions and check without bias, it is going to give the recommendation to the person who is utilizing who is devising the AI algorithm. So AI integration is the core component of 6G, because we want self-autonomous devices, autonomous devices, autonomous networks, autonomous intelligent networks, and they have to think themselves, and they should come back from, if any error occurs, automatically they should be resilient enough to come back to its original position and continue their work or their performance without any degradation in their performance. So in that way, if you look into that, AI because definitely the vendors, the proprietors or the owners, they never want any downtime. So always downtime must be very, very less. They want all the time must be up. So that if there is a downtime, definitely there will be the profit will be less. They don't want the profit to be lost. They want always the complete profit or the 100% profit. If it is so, then the downtime must be very, very less. 0.02, 0.01 like that, 0.01%, not 1% like that only. They don't want any downtime. So downtime is also calculated, and they don't like downtime. If downtime is not required, automatically the devices should be punctual and they should operate at a faster speed. If they should operate at a faster speed, the devices or the machines participating in the industry, participating in the communication, they should know about themselves. So the devices must know what they are and what they are doing. You could have seen LLMs, large language models, and retrieval augmented generation, RAG, and the agentic learning. A lot of mobile agent technology is coming into picture, and a lot of agents are going here and there. If you apply for a loan, automatically it will come and ask, what is your requirement, what do you want, like that. It is asking whatever you say, automatically it is filling the cursor moves and it started filling all your details, whatever you say. It is able to identify your voice and it is filling everything. After filling all that, automatically it will be submitted and you get your loan or whatever. So these are all agents, so software agents. So these agents, the agents can be software agents, intelligent agents. If intelligence is incorporated, mobile agents, if the agents are moving from one device to other device, mobile device agents, like that, a lot of devices, a lot of agents. This artificial intelligent agents can be incorporated, and this agentic technology is going to rule the world in the near future, definitely, if they are incorporated with the large amount of intelligence. The AI continuously monitor the network traffic. Many places you can see how it is monitoring bottlenecks, whether any problem is there, whether any intruder detection, botnets, whether any information is lost, whether any scam occurs. Automatically, the network must be error free. Then only you are able to transfer the data, and reliable communication is possible. In order to get a reliable communication, definitely what has to be there? There should not be any bot or botnet which has a bad characteristic to scam our information. So in order to avoid that, the botnet detection of bottlenecks, detection of bots, bad bots, and alleviate the bots, neglect or remove the unwanted people who are entering into the system and avoiding the hacking the system. They should be avoided. So this must be known to the system, not only to the people. It must be known to the system. That is why AI is being incorporated into 6G at a faster rate. The communication is going to be. There is no time to detect the hacker also. So in that case, we need AI to manage itself. That's why AI to manage the networks dynamically is given there. Network fault detection, correction, like that is given. And dynamic traffic management, network traffic management, because highest amount of data is going to be transferred. Definitely predicting the traffic patterns, how the traffic pattern is going to be. If the traffic pattern is going to be like this, whether the network will withstand or not, that has to be analyzed. And network automation, zero touch provisioning. That is, you are not supposed to touch the system and repair the system. Automatically, it has to come back to its original position if anything occurs. Autonomous network, reconfigurable networks are there, reconfigurable computing is there. All these are required, will be there at the back end for the communication using 6G technology. And predictive maintenance. Before the error occurs, before the fault occurs, automatically we should know that this type of problem will occur if the network pattern is going to be like this, if the traffic pattern is going to be like this, if the data pattern is going to be like this. In that way, you should understand, the system should understand and do the predictive maintenance. All this is some of the application. And coming to 6G again, we are going for holographic experience and immersive virtual spaces. Already in 5G also we are doing, and we can also extend it to 6G, will enable the real-time holographic communication. You can touch the object. If you go to some places or malls or somewhere else, you can see there is a room. You can go there and they'll be giving you the Oculus glass, and you can wear that glass AR/VR camera or the glass spectacles we are wearing, and you will be immersed in the application. Because you can immerse yourself into the application because it is virtually available, but not really available. Virtually available, not really available. So in that environment, you can immerse yourself into the environment, and you can feel the presence of the objects that are available in the virtual environment. That is your hologram, interact with the 3D holograms, and though the present physically they are not available, you can feel their presence even though they are not physically present. That is holographic experience that can be done by 6G and done through 6G, and virtual meetings, remote collaboration, entertainment, and all that are some of the other features. And coming to the applications again, it will enable the 3D video calls and extended reality, virtual tourism and education, some of the applications. And technologies enabling 6G, you can see terahertz spectrum, the key to the ultra high speed spectrum, terahertz spectrum, 100 gigahertz to 10 gigahertz is the operating frequency band of 6G, and massive bandwidth is required because that is the massive bandwidth. Speed is up to 1 Kbps and low latency sub millisecond performance. And signal loss and propagation issues are there with this. Atmospheric absorption is there, signal attenuation is there. That is why we need to develop a lot of algorithms. Line of sight communication always won't be available, and a lot of obstacles may be present in the line of sight communication. How to avoid that? Further signal processing techniques are required. High frequency transceivers are required. Transmitter come, receiver is the transceiver. Transceivers are required. And with respect to that, you need the infrastructure. How the gigahertz waves will move or will pass on to the existing hardware technologies, that should be taken into consideration. Intelligent reflecting surfaces, because smart surfaces for optimizing wireless communication is intelligent reflecting surfaces. The surface itself will reflect the signal so that you are able to amplify the signal. In an amplified manner, you can visualize you can hear the signal. So that is the other part of an application. So intelligent reflecting surfaces, that is smart surfaces, your walls, your windows, your ceilings, can reflect and refract and scatter the signals to improve the network performance. That way, the building can be constructed, smart buildings can be constructed in such a way that communication can be in a better way, that it can execute 6G communication within that building. And reconfigurable elements can be utilized in the construction of buildings. A lot of research is going on in the construction of building materials also. If it is like that, and what type of materials they can go for, meta materials and electronic circuits, what type of circuits they can go for in execution of this particular technology, And in urban environments, you can use IRS and 6G. Already 5G is there. 6G has to be integrated with the 5G by optimizing the signal propagation. And the last one is quantum communication. Quantum communication, as I said, ultra secure communication with the quantum technology. Highest security is possible by means of quantum, unbreakable, because you cannot divide that bit beyond that, because already it's a quantum bit, you cannot break it. When you are not able to break it, it is an unbreakable encryption technology and highly efficient data transfer. If it is highly efficient data transfer, how will you break it? How will you go inside and how will you hack the data? Nothing will happen. So that is why people are waiting for quantum communication and quantum bit encryption, etc., etc. All these are some of the quantum cryptography. All these are some of the techniques behind quantum computing. So if it is incorporated again in the 6G communication, then it will be highly secure. Quantum encryption, quantum key distribution will provide the foundation for ultra secure communication that can be incorporated in 6G, because the scientists and the people are thinking in what are all the ways, possible ways, that execute reliable ultra high speed communication as possible. That is why all these technologies are blended in a way that 6G will come into reality. And coming to the applications, critical in military, government, and financial sector, definitely the highest, the most sensitive data is the government data, the military data, and the healthcare data, financial data. All these are the highly sensitive data. So the critical infrastructure is required. And the quantum encryption, again, you need to have the 5G, 6G background security mechanism using quantum. And for communication, already beamforming techniques are used, MIMO are used, multiple input and multiple output technologies are used. Again, you can direct and focus the radio signals on specific users' devices. Multiple inputs you can receive and multiple outputs you can take it, and they should not collide with each other. And there are a lot of techniques used to diversity technologies, diversity functions are used so that the signal won't collide with each other and they'll go, even they are all emerging from the same location, they will go in their own direction, their own frequencies. You could have heard about frequency division, multiplexing, space division, multiplexing, time division, multiplexing, code division, multiplexing, etc., etc. A lot of techniques are available. Beamforming is one other technique. Advanced beamforming techniques for directional focus towards the destination, interference-free spectrum, which will carry the information, which will be utilized for 6G and dense urban areas and industrial IoT to collect all information about the factory devices, which are factory machines, and each and every machine will be producing largest amount of data every instant. How to take the data, how to collect the data, how to transfer the data, how to understand what the data is going to tell, and all that coming under industrial IoT. For that, communication is required, 6G communication is required. You can see CV Citizens Broadband Radio Services, CBRS, and licensed bands are available, LTE, long-term evaluation after 3G, 3G PPP, 3G PP partners, private partners understanding, and CBRS is 3.5 gigahertz shared spectrum. I said about dynamic spectrum sharing, operating under 150 megahertz. You can have radars and periodic access licensed holders are using the shared spectrum. Unlicensed people, they are not able to use the spectrum. Primary users are there, secondary users are there, and there is a consensus which will arrive between the primary users and secondary users. A lot of algorithms have been developed in order to share the spectrum. And coming to 5G, 5 gigahertz, 5G and 6G, 5 gigahertz and 6G unlicensed 500 plus megahertz is used, replaced by the Wi-Fi and available for near field communication and near devices. So Citizens Broadband Radio Service again uses the LTE network, long-term evaluation network. You have macro cells and small cells and CBRS outdoor cells, and how much is the percentage of cost of using that frequency is given in this particular slide in indoor and outdoor. The key drivers for the private networks are guaranteed coverage, network control, performance, and security again. So we have private networks also. For that also you have the radio access network, packet core, application, subscriber management. All these are parts of the communication network. And macro network subscriber management has to be done. Embedded in the packet core and the RAN, you can have some other devices also. So I can show the devices. Authenticated server function, private networks in 5G. Overall participating in that is given in this particular diagram. The data network is there. 5G standalone private network, how it will be, how it will function. So that functionality is given in terms of a diagram. Authenticated server function is AUSF, NRF is network repository function, SMF is session management function, UPF is user plane function, and UDR is unified data repository, UDSF is unstructured data storage function, UDM is unified data management, and access and mobility function is AMF. All these are part of the 5G private network. G node B is the base station, nothing. So even in LTE and 3GPP and all, you could have seen G node B. It is a tower. It is nothing but a tower or a software-defined radio. If it is a hardware, then it is a tower. If it is a software, it is a software-defined radio. On standalone 5G NPN reference point architecture is given here. So how the connectivity is, how the points are, how the devices are getting connected in a private 5G network, the same diagram. And mobility management entity and the serving gateway are included in this diagram. And RAN is again radio access network. All the software are done using the COTS component. COTS are components on the shelf component hardware. So the embedded the distribution unit and the central unit, you can have the mid-hall network, front hall, mid-hall, back hall networks are there. So they are used for providing interconnectivity without any frequency delay between any two units. That is the mid-hall network, open RAN. See there, all the RAN radio access networks are available. How you can split the entire network into distribution units, and then you can transfer the data from one part to the part of the network. Hello. And to execute the 6G technology, again, you must have the novel antenna technologies, 6G network, novel antenna technology, multi-input, multi-output, I said, adaptive beamforming, And applications are again wearable devices, smart cities, and industrial IoT to bridge the digital divide. Global connectivity and inclusivity is the main criteria behind all this. Energy efficiency, environmental impact, security, resilience, digital inclusion, affordability, and coverage of low density areas, EMF, electromagnetic spectrum awareness. All these are some of the factors which have to be taken into consideration under when you implement it in the society. That these are all called as societal impacts. Healthcare, you have to healthcare access. You should understand how much is the radiation which will affect the patients, that also affect the people. That should be taken into consideration. Because of the implementation of 6G, the number of patients in a particular area should not increase. That should also be taken into consideration. Education, online education, digital learning tools, a lot of tools are available. Microsoft has released a number of tools, and many companies are releasing many tools that needs communication strategies. Advancements in education and learning, transforming education using digital tools, that are, virtual classroom, holography, AI-driven tools, and you can see how throughout the world the students are getting connected with the video conferencing and high definition content without buffering or latency issues. If it buffers, you are not able to visualize the data. And implications of smart governance, also you need 6G. So for government, definitely they'll start with the government only. It must be simple, it must be moral, it must be accountable, responsive, and transparent. In that way, smart governance implies all the entire information should sit upon. So that is why 6G for the smart governance. That for that question only, the block diagram is given here. So data-driven insights, they want to get from the people's interest what they want actually. So that can be made as a pattern. So every state, and our state is also having a data center which is run by the chief minister, and a lot of people are working on that. They'll also analyze all the people's queries, and they'll analyze what kind of services can be provided by the government to the people, and who are all needy, who want this or who want that. Like that, they'll come to a conclusion. People's interest, they can arrive a conclusion. For that, data centers are being used for e-governance. They are replacing that. Real-time data processing, high-level connectivity for public services to to give the solution at a fastest manner. They want e-governance. And for that, again, 6G is used. Smart cities and public safety. Again, revolutionizing workspaces with the digital experiences, music. Again, coming to entertainment, book publishing, gaming, advertising, films, TV, music, sports, etc. All these are some of the workspaces where our digital experiences will come into play. For that, we need the fastest communication, remote work, virtual offices, immersive environment, and all that. Virtual workspaces, next generation gaming, AR, VR, and mixed reality, cloud-based gaming, and seamless and immersive experiences, live events, 360-degree immersive experience, and all that sports. So with all this information, what are the challenges in 6G development? We need spectrum is not available within the limited spectrum. We are not able to communicate at a faster rate. That is why we are going for Wi-Fi and all light fidelity. We are going for to utilize the fiber optic communication for this, and we can use the LED spectrum also. 6G aims to deliver ultra fast speeds up to 1 Tbps, as we know, to handle the massive amount of data, and it has to be, the spectrum has to be expanded. That is why we are going for dynamic spectrum sharing with the primary users, and sharing between secondary users and all. And there are a lot of algorithms used in that particular manner, how in an optimal way we can utilize the spectrum. And millimeter wave bands which are used in 5G, but it is not possible for 6G to use the millimeter waves. In addition to the millimeter waves, we can use the terahertz spectrum also. The issues and challenges are spectrum scarcities, limited spectrum availability, interference, congestion, global spectrum. Because one place we are using that, North America or South America, we are using one particular set of frequencies. We can use here. There is no frequency clash or frequency spectrum clash will occur. In that way, the spectrum has to, because the entire globe is divided into 3-4 regions for spectrum utilization. So one portion of the spectrum is used in this one region. The other portion of the adjacent region will be utilizing the other portion of the spectrum. In that way, spectrum clash will not occur. That is this. So further, there are committees, there are forums, there are people committee available. They'll decide how the spectrum will be coordinated with each other. You know about 2G, 3G, 4G spectrum, about a spectrum in our country. You know very well about that. And we have to, it is essential to harmonize the spectrum allocation. So what type of frequencies you can use, what type of frequencies you cannot use. That is what spectrum allocation is. What spectrum you can use, what spectrum you cannot use. Because which is the frequency through which you can communicate. That is what called as the spectrum. Nothing is there. So the speed at which you transfer your data is known as the spectrum. So new spectrum management technologies have to come into picture. That is the challenge in 6G. And high energy consumption and environmental impact. Balancing speed with the sustainability. If the speed is like that, whether it is able to sustain for how much time. So again, it is a problem. And for that, increased energy demand will occur. Environmental impact is also there. Sustainability challenges are there. So energy saving techniques, low power components are required. Adaptive beamforming techniques are required. Intelligent reflecting surfaces will also be used for giving energy from their side that can also be utilized, and renewable energy source, solar panels like that. So all this will solve the high energy consumption problem. And security concerns, again, you can go for quantum and all. AI-driven networks, autonomous system, they all require security and privacy. Cyber attacks will be there, data breaches will be there, botnets are there, AI vulnerabilities are there, privacy concerns are there. All this can be avoided if you go and apply with quantum encryption, and blockchains can be utilized. Blockchain communication can be incorporated into 6G development. Unbreakable security, as I said, self-healing systems, as I said, it will come back to its original position if any error occur. Cyber attacks in real time, and integrity of the network should not be spoiled at any point of time. Storage, processing, etc. And technology, coming to the technology complexity and scalability, managing the complexity of the 6G networks, quantum communication, beamforming, massive IoT, scalability, all the peers spoken. The challenges are technological integration and scalability challenges. If it is beyond a particular area or particular region, then how the scalability will be taken into consideration, and upgradation if it is there. Then you can go for a federated learning kind of thing. Already you know what are the learning techniques: supervised, unsupervised, reinforced, all the semi-supervised learning techniques are available in machine learning. We can go for federated learning technique, which can save time and avoid the issues related to scalability. And again, navigating the regulation. What about the regulation? Global regulation, that we should security protocols, whether everybody is accepting the same security protocol, whether all the countries are accepting the spectrum allocation, and all the countries are accepting the interoperability. IoT devices interoperability is the major challenge. Application interoperability, network interoperability, different networks, different applications, different devices, device interoperability, network interoperability, application interoperability. All these are some of the challenges, and all these challenges must be taken into consideration. Global harmonization and standards. There is no a specific standard for communication throughout the world that has to be standardized. All the companies and all the people, all the pioneers who are all participating in the development of 6G, they should come together, and all of them should accept spectrum allocation, privacy and security laws. All the laws are not in Saudi Arabia. Some laws are there, some cyber laws are there. In India, some laws are there. In US, some laws are there. All the laws are not equal, but privacy and security laws are different from country to country. So everybody should coordinate and synchronize with each other's views and points. Establishing the global regulatory bodies, and the developing system should be agile and flexible. And the roadmap for 6G is finally this one, 2025 to 2030 and beyond. You can see what are all available here. Industry efforts, research initiatives, and 5G standards. Already existing 5G standards are there. 25, 26, 27, 28, 29, 20, 30, 31. You can see key hardware and software technology during this time. And 6G testbed will be made available, and 6G evolution, 6G standardization, beyond 6G study specifications, and all that is given in the timeline chart. Accordingly, people are working on that. Steps for transition from 5G to 6G, if you want, 1G local voice, 2G global voice, 3G mobile internet, 4G mobile broadband application, 5G ultra digitalization of societies and industries, ultra reliable low latency communication, 6G cyber-physical interaction, Internet of Sensors, extreme connectivity with terrestrial and non-terrestrial planetary communication. All this we are expecting past, present, and future of the mobile networks. And all these are some of the additional information about 6G, high frequency spectrum utilization, MIMO, intelligent reflective surfaces, software defined networking, and network slicing. I didn't say network slicing is also an important concept. SDN is important concept. SDR is an important concept. Network function virtualization is an important concept. Edge computing, AI, machine learning integration, fiber optic backhaul networks, modular designs, and sustainability consideration must be taken into consideration. Energy efficient network designs and eco-friendly practices have to be incorporated when you design a particular 6G network. And low power consumption components, dynamic power management, intelligent network design, edge computing, and localized data. Local data processing has to be done in that particular region, and then it will be made as a global data processing. So you arrive a consensus in the local data processing region, and this consensus can be taken towards the global data processing. That is what federated learning is doing. And renewable energy sources, you have to utilize intellectual interconnection via the reliable energy sources, solar powered base stations, wind power, energy storage solution, green data centers. And the role of AI in 6G, AI, you know very well about what AI is doing, how AI can be incorporated. AI enabled 6G network, it can do botnet detection, it can do channel estimation, how much data is being utilized through the channel, by the channel, and modulation recognition, what type of modulation, amplitude modulation, frequency, phase modulation, what type of modulation is being recognized, traffic classification, traffic network, traffic prediction, data catching, how much data has to be in cache, how much data has to be in the primary cache or secondary cache, or in the hardware, where, or in the cloud, and intelligent routing techniques, radio, shortest path, or the optimal path, radio resource management, network fault management, self fault adaptiveness, self fault identification, resilience of the network, mobility management, energy optimization, intrusion detection, traffic anomaly detection. All these are some of the factors of AI in 6G to get a reliable 6G network. So autonomy, efficiency, and quality of service are the factors which AI will provide for 6G networks. Again, the same thing, federated learning AI collaboration. Cognitive, I didn't talk about cognitive radio networks. It is a very big concept. Cognitive radio is, again, in spectrum sensing, you can go for cognitive radio networks. AI powered edge computing, I told you. Finally, 6G will revolutionize the connectivity, AI driven networks, offering self-healing, self-optimizing, highly adaptive capabilities, technological advancements, terahertz communication, quantum computing, and advanced beamforming. Under global connectivity, you can go for interplanetary communication. Under security and sustainability, you can avoid and address risk, privacy concerns, and other factors critical to 6G networks. Collaborative effort is required from all the people who are all involved in the technology and innovation, and industry partnerships and academic and research communities. They should come forward to bring the full potential of 6G. And some of the MCQs are available. And I have some references. Qualcomm is doing a wonderful research in this. They are a pioneer in this. IBM and all people are doing a lot of research. Many companies have been involved. So with this, I'm closing my session. And any questions?
Is there any queries for the participants?
So I'm not clear about the concepts. Related to 5G and 6G. We have also done some research in 5G. and we have taken some objectives. We analyzed the barriers in 5G communication and what type of algorithms will break the barriers in the 5G communication. That was the research actually. So if there are no questions, shall I whether I have made the concept clear? What is 5G
Yes,
and
ma'am.
6G?
Yes, ma'am. We don't have idea to ask any questions, ma'am. Yes, ma'am.
So just it is a foundation or a
Yeah.
overall view.
6G, no.
I didn't go in detail with all the information or the circuitry or the network information. I didn't go into that actually. Thank you. Thanks, Menaka. Thanks. Thank you very much for the opportunity given for me to handle this particular session on the technology through where we are working on the same. That is why it is possible for me to shed some light on why 5G, why 6G, why the evolution is going to be like this, and then and there, why it is evolving, and what are their ideas, because they are going for planetary communication, interplanetary communication. It is required actually because they are sending satellites. Automatically, they want to get communication. They want to communicate to the people who have gone there to do some research. So communication is required. Interplanetary communication is required. If that, then it must be very, very fast. You must see the speed of the satellite. And according to the signal should also, whatever signal you are transferring, that should also be competing the speed of the satellite so that communication is possible. Many things have to be analyzed actually before drawing a conclusion or before doing the experimentation. Thanks, Manaka. Thanks for the opportunity by the LLM College of Engineering Technology, and thanks for the organizing team. Thanks to the principal, HOD, and all other chairman and other people who are all involved and who have supported a lot in conducting this kind of ATAL workshops, ATAL FDPs in our college. Thank you very much. Thank you.
Thank you, ma'am. We hope that your presentation really empowered our ATAL participants. The focus of our presentation really inspired the way for all the minds to rise the expectation towards 5G to 6G technology within few years. Thank you for making one step forward into the future of sixth generation technology. Thank you very much, ma'am.